we've downloaded and which. Okay, are we starting? Oh, okay, we have about 30 people, so we can. Okay, so you can.
I think we can start formally.
Okay. So in that case, to also follow the next presentation, you can load your Python, the one I sent to the comment section. You can download it and save it somewhere on your drive. But the Python notebook, actually, you can run it without saving, being worried about the data. If you want to see where the data is, you copy the URL. I'll show you when I start with that particular notebook. But this is how you can load the data, the Python notebook that I sent on Google Colab. So when you come to the file, after just logging in with your Gmail account, you come to file, see, you have upload, you have open. Open notebook means that you have that particular notebook already in your Google Drive. So if you want to open, you can just open, but I don't have it there. So if I want to open, so I just put this, then I now browse for and locate wherever I saved that particular notebook on my local disk. So in this case, this is it. I've opened it before, so I can upload. But I already have that. I don't know. I tried that already. So just to demonstrate to you how you can do that. But if you have, let me see. I'm going to run in my Jupyter notebook because I have Python software on my laptop locally. So I don't need this. So if you want to run along as we go, then you can do it in Google Colab. Good. So let me return to my Okay. Can you see my screen now? Please, can you see my screen?
Yes. Yes.
Okay. 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 Then we can continue. Start now. Okay. So if you load, assuming you had, if you have good. Yeah. Good. Let me just, oops, I nearly forgot this. Good. And then I'll talk about this. Okay, here we go. All right. So I've shared a particular code, is code in the chat again. So if you upload, if you upload the Python file in Google Colab, it gives you error when you are trying to import these packages. I hope you can see my screen. It gives you error when you are trying to import this package. So you have to manually do that by using the code that I just sent there. the comment section. So when you copy that, just put it at the beginning, create a cell, and just drop it there and run it. When you run this just like that, and then it gives you error, just put that particular code. That gives you an opportunity to download the package. Some of the packages are not automatically embedded in Google Colab. So when you are running any code at all and you have such package errors, you need to actually import it manually, and that particular code helps you to do that. So this particular one will give you, if you use this only this in Google Colab, to give you error. So just put the code that I just dropped in the comment section. Just put it in on the top. Size power, like something, exclamation, and then that particular thing is a code. So just put it at where my cursor is right now before running it. So good. So this is where we are going to look at spatial analysis. Spatial analysis, we are just trying to look at it from the geographical perspective. And then we'll look at, so to be able to run spatial analysis, you need to have some, you see, the earlier data set that we use for our regression, we didn't have geometry column. If I say geometry column, it means we don't have coordinates that to locate the point on the surface of the Earth. So those are the things that we lack. If you don't have those things, you can never do spatial analysis and data analysis. With spatial data science, a subset of the data science, which is as pros. So data science, spatial data science is a component of that particular axis, which new data scientists are exploring these days. And it's a space that a lot of people don't go there because it's kind of complicated and stuff. You have a lot of machine learning models and then plotting of maps and stuff. So with this, you can either, based on what you are good at, you can either use the Python platform for all this analysis, or you can also use the R software. And mind you, the R software is not only for spatial analysis. You can also use it for this regression that we did, depending on how well you are conversant with a particular programming language. At least you master one or two. If you master one, then that gives you a stepping stone, or it gives you the edge to other things. But in Python, if you want to start doing this coding stuff, I largely recommend you start with Python. Yeah, with Python, you understand what Python is doing, what the codes do, and if when you see a code, you're able to appreciate it. But don't be like, I want to get everything. Most of the times, just understand what is working. If you're having challenges, ability to use these tools to solve problems. It's not your ability. I may ask you, what does this package, does this particular thing? 2 hours to analyze the data is absolutely right. So okay, because no one can ask you, what does this do? What does this package do? How to analyze the data that will solve a problem or give an insight into a particular problem. Good. So did 23, and we have those geometry columns. It means we can plot wherever those properties are located. And if you have a data, another way we can also use this thing, use geometry column to analyze data is that, okay, I have these properties. Let me see how distance away certain projects influence prices. So if I have geometry column of each of the properties, I'm not talking about data, personal data, because when you have the personal data in your research or in your data sets, you need to talk about ethical reflections. In this space, London here, they have a lot, they are serious about personal data. What we know, sometimes we normally do in Ghana, without taking somebody's consent, we do a lot of things without doing anything, without taking any precautions. It's very serious here. The moment you leak somebody's personal data, you're in trouble. They have a law, and then they have lost work. So what if you have a data? My dissertation that I wrote, there wasn't personal data, but you need to actually go through ethical approval of your data. So you tell us where your data is coming from, what are the columns in that particular data set, and it will go to the department ethical committee. So they will look at where your data is coming from, what are the columns. If it satisfies the low risk, this one, then they'll give you approval to start before you can even start your dissertation. So you have to go through all that. And then after you are done writing your dissertation, you have to talk about the ethical reflections. What ethical reflections did you encounter? What did you encounter in the data? What if you have, so in this case, if you have a housing data that has personal data in terms of address, even address, postcode, GPS address, those are personal data. So if you want to do spatial clustering, what we don't normally use the postcode of that pattern. So because you have to go through a lot of approval to be able to work with that particular data and without leaking that particular data, because that address identify an individual. I hope we get it at this point. So if you have postcode, it's better to take up that postcode. So what we normally use for this is the latitude and the longitude of that particular point or that particular property, which we term as the geometry column of that particular data. Good. So without geometry column, forget about spatial analysis. You can only do these normal modules, build all these normal modules. Good. So in this case, we'll be talking about clustering, how we can do clustering. And then clustering is in a nutshell, it's just we are trying to find people who have things in common and group them together. And or people who have things that are not in common, they have dissimilarities in them. We group them together, people and stuff. So in this case, we are going to determine and we are not going to use any formula from our head. This model, that is one good thing about these programming languages. These people are really advancing. Yeah. So they've done everything, making life so simple. If you know the models, and let's I forget before we even end this one. When you want to get into these programming languages, there's this thing called Stack Overflow. You are going to face a lot of challenges coding. You are going to face a lot of errors in your data. So if you run a code and you get an error, you ask chat. First of all, you yourself search about it. If you're not getting any response, then you can seek somebody who has experience in that. And one of the space that you can get your questions, the answers for your questions is Stack Overflow. If you type Stack Overflow, you see that page. Experienced programmers are there. Whenever people, beginners, whoever faces a challenge, put it there, somebody will come and answer. So whoever answers, so you just go through the responses and look at how they address that particular similar problem. Because whatever challenge you face, somebody has faced that before, because you're not the first person to run clustering or you're not the first person to run a regression model. Yeah, so that is basically what clustering means. We are trying to data point. Let's see which of the data points are similar. We group them together. Some of them, which of them are also. So we look at it from both similarity and then dissimilarity aspect. Then we group them together. Yeah, that is all about clustering. And then clustering, one thing to also note is that clustering is an unsupervised machine learning model. So those of you who will be advancing into this programming stuff, the moment you want to enter into the data science space, you definitely face data science space. You definitely face this clustering stuff, models and stuff. And then it's unsupervised because it doesn't have labels. We don't train the model. We don't use train data because if you noticed the random forest that we ran, we had a text, we splitted the data, we had a text data, and then we have a train data. So after training the model, okay, we are exposing the data to this particular model. Look at it, identify the pattern in it. Now, then we use the text one that is not seen by the model to see if it will perform accurately. That is what work. That is what is done in that particular process. Now, but in this space, so that one we can term as a supervised machine learning model. But here on supervised machine learning model is that we don't train the model. We just feed the model with the data. You yourself just understand the data, give us patterns, understand the data, and then run something for us. So that is why it's called unsupervised. It's not labeled in that regard. So the algorithm in that model just tries to find patterns, try to understand or the structure of that data. So that is one thing about clustering. And then we'll get there. And with clustering, we have various methods that we use in that assay. Just like the regression aspects, that if you want to look at impact, if you want to look at impact, if you want to look at prediction, which of the methods that will help you do that. And you don't just get up to decide on a particular method, like I mentioned. Choice of method will be influenced by the research question. Whatever you have as a research question will determine the type of method to be used and stuff. So those things helps you to choose your method. If you're going to choose a wrong method for a particular thing, the whole thing will be one. So let's just proceed with our presentation. Then so in this particular presentation, we are going to use various clustering methods. One we call K-means clustering, and we have DB scan. DB scan is a density-based scanned model with noise or something. We'll get to that point. Then we have with that density-based clustering, density-based the DB scan. We call it DB scan. With noise, we'll get to know the full meaning of that particular this one in a bit. Then aside that, we have another one which is called a hierarchical design, and the max P. Again, we'll get to know how it's being used and when to use those things, and to analyze the housing price and population data in London. So this time around, we are going to use housing data and population data in London. Now, we are using data from London because accessing data from Ghana is really, really difficult. Like I said earlier on, even census data is not open. You need to write letter to. The last time I tried to access, come on, I didn't get any access to it. You need to write say for approval and stuff. So we'll commence, and then okay, so then we describing and then analyzing the clustering results. So after we do the clustering, we can analyze it using certain tests, like the Sweight test, which we'll get there. Then over here too, we still have to look at this code. Actually helps you to know what time of the day at what time. So this is just for time, and then year. This is nothing necessary. You can take it off if you want. This code is just trying to give you date when. So if you run this, it will give you the current date, not the previous date. So you see, it gives you a date, a time zone of where you are and stuff. Then we move on to preparation. So first of all, we are going to download the GIS and then London housing data from the London data store. That is where we access this particular data. So when we download that, this is online. If you want to download it, you can just, when we get there, you can just copy the URL and put it in your browser. It will automatically download the data. So London is divided, it's a very huge geographical space with different boroughs. If I say boroughs, they call their boroughs as like towns. Like when you come to Accra, you see Adenta, Spiritus, and then Ablekuma, those things, yeah. Something like that. So London is so huge, about 9 million people. So they have different boroughs too as well. So those are the data sets that we're going to be using for this clustering assignment. Now, so the same thing, whatever you're going to do, you will need packages, like I mentioned earlier, packages to to develop, to do your analysis. So we import them. Now, after importing them, so after importing these packages, I think some of them takes time, so I'm not going to be running. I think I've already run them. So we just have, for the sake of time, I know some people are already exhausted. Yeah, so this code, this is the URL where the data is seated in a space remotely. It's a zip document. So if you want to download it, this package, so we have comments here that will make you understand what the W gets. So this exclamation, we are manually downloading that particular, what it means that we are downloading that particular. Oh, come on. Good. Please, can you see my screen? Can you still? Hello?
Yeah.
Okay. Okay. So if you want to download it from the space, this is what you do. So you run this code and then it will download this for you. Then after you've downloaded it, we have to put in a particular, because it's like we call it a polygon. When you download it, you see someone has. We can okay. As when we talk about shape file, I hope some of you have done. Yes, you guys did. I remember you guys did extensive GIS stuff during your first year. You know what shape file means and how it's been saved. If you see the SPH or something, you see that SHP shape file. That is the file that you are going to load on the platform. And then if I say send me the shape file, sorry, that doesn't mean you should send me. So if you open the folder, you see different folders in different formats. So when someone says send me the shape file, it doesn't mean you send that single one. You should send all the packages that will help the file to open. So if you download the boundaries for this London, this particular code, if you download the boundary of London, you see that we have a lot of different files in that particular folder. And what we need will be the shape file. Shape file is like the map, the shape of the polygons in that particular thing. So right now we are reading it remotely. But however, if you download the document, the files, the data, and you locate it in your machine or in your local folder, and you want to read it, this is how you can read it. You can also mention the path where this is where the file is located on your computer. Then now use this to read it. So because you already told the Python platform, that Jupyter platform, that the direction of my file is this. So you are communicating to the computer, go into my computer, go through this process, and go and load this particular data. And the name of the data will always be the last one. That is how you load it manually. If you tried there, you want to actually have a view of the data set that has been loaded. And if you are dealing with spatial data, the first thing you can do when you are being given these shape files, the first thing before you even start loading or you start your analysis, open the files and observe what is inside. Sometimes you might be thinking that you downloaded the right data, but when you load it, it's a wrong data. So you can open it. So most of the times we use QGIS. I've not used ARC before. You can use QGIS to observe the data. Just look at the shape. It's actually representing is what you are looking for, not like a monkey, that a shape of a monkey or somebody who has drawn something. So you are confident that the GeoPackage file that you are downloading or the shape file that you are loading is the right one. And then sometimes you can also visualize, you can also just open your data set in Excel and look at how it takes before you load it into the Python platform. So after loading this, so we now save our file. We save our file in
today's phone. Yeah, nobody learned anything.
Are we okay now? It's like that, eh? Don't be so hard on yourself. It's like that. I told you that's why I started by my first day in class, because you guys are new to all these things. That is why it's looking like you don't understand. You feel like it will actually get to you. Feel sad that you're not getting anything. But it's a privilege to be introduced to these kind of things, so that at least you know that things like this exist. And then if you want to go into that field or that space, you can do that. Yeah. And then no one is going to test you on whatever we are doing today. But it's good for you to know that these are the things that you can do with certain things. If you come to the global space, you realize that it's not about theory. It's about what you can actually do, the simple things. Mind you, if you are going to do masters and you understand this, then you take the step now to start understanding this basic stuff. Those of you who will be going into, maybe you want to go into the quantitative aspect of analysis. Somebody is there who is a researcher. The person is good at qualitative research. Somebody is good at quantitative. But if you want to go into quantitative, if you want to do PhD, if you have this kind of skills, it helps you a lot. So it's fine if today you're not getting anything. It's normal to feel that way, but just understand that things like this exist. When I came, I didn't know these things all exist. But today I'm able to pass on something to you guys to also tell you about these things. Yeah. So, good. So that's just by the way. Let's continue. So this particular we load it with a package. We didn't use read.csv. We use what we call GeoPandas. GeoPandas is a package that helps you to load geospatial data into Python. So that is why it's called GPD. The first one is PD, pandas, just pandas. The first one is GeoPandas, so we save it as GDP. So geometry data frame or something, geographical data frame. So that is what is shortened to be like GDF. You can actually represent it whatever you want, however you understand it. It's all up to you. Now, so after representing that, now we'll now look at the info. If you want to look at the information about the data, this is you call the data and then info parentheses, you run the code, it gives you the information about the data point, even the memory size of that particular data. You see all those things. You see that the data types in Python, we have integer, we have object, and then we have even float. So the school that I'm talking about will help you understand all these basics. Is called W3 school. If you are interested in understanding Python, you want to start as a beginner, I recommend that particular platform for you, because that is what actually helped me during my beginning days. Yeah. So if I look at the information, then it gives you the columns too as well. Here you can see that I can visualize, I can look at the head of my data frame. So you can see that I have my MSOAs. This is just like the middle, it's just like the middle layer super output areas. It's just like a name given to the areas, the zones in London. So it's just a representation, a unique identifier. Then this is the most important part. We have the longitude, we have the latitude all here. So this is a geographical data point. And this is what I was talking about, geometry. Very, very important. So we have all those things here. Now, if we have this, now we have to read our CSV file. The CSV file is just about the house prices, which is the value of the houses in London. So now we use DF, so we'll read it using pandas, not GeoPanda, because it's not a geographical data point, it's not shapefile. So we just read it with the PD. We're not going to read it with GPD. So GPD, so it's PD dot read. This is a path. So if you want to also download that particular data set, just copy the URL, put it in your Google, and it will download the data for you. This data is also housed in my professor's GitHub account. The GitHub is a place you can actually do a lot of things. Keep your stuff over there. Now you can also look at the head of the data that we just read, the CSV. So you can see we can have the code, the unique code of this particular, the addresses they have here, they use. So we have backend is borrow here, backend, and then that Genham. These are the places that we have. And here we also have data from 1995 till. So we wouldn't use all of them. We'll filter what we want to use to do the analysis. So here we have the median, we have mean values, the measure. So we can have median, we can have median. So whichever you want to use in analysis, you determine which of them you want. This is because it's 5. That is why I don't know that there's mean values also there. And there are also mean values. And so these are the mean values in London. They have these are the median. We have mean values too, because when you put maybe 30 here, so when you put 30 here, because I've not run the code, you wouldn't see it. I have to run from the beginning again. When you run this, you see there are a lot of them. So you just have to put a number here like 30, and then you see a lot of them. Then you see that there are mean values also in there. So depending on what you want to look at, if you don't want outliers to influence the value, you can use the median stuff. But over here, we are going to look at the shape of our data. Sorry. So when I look at the shape of my data, you can see that I have this code gives you the shape. You have 262,000 rows, and then we have 5 columns, and then these are the 5 columns. It means if you open this kind of data in Excel will compress some of it because it's huge. It's huge. And so over here too. So what we are going to do is that in here, this is the original data shape. This is the original data shape. So over here, I pick the original data set, and I'm trying to filter and then create a SAP data. I'm filtering only the mean, like I showed you here. There are mean values down there. So if you see, you see that there are mean values there. So I'm creating a new SAP data and keep it in a different one. So when I create that, I want to see the shape of it too as well. So this one picks only the mean values, excluding the median values. So when you do that, it has created a new data set with the shape of 983 rows and then 6. So let's just have a view of it. And this is what we see. The index, and then we have is how the index of the data point that has been selected. Then we have the code. Then code. In the code, we have year 2017. So I want only values for only year 2017. You can also try and say I want only values to look at the category. So this code will also take that particular only the data set that has the type category. So we pick the mean values. We are going to do something with it at the moment. So when we do that, we drop. Okay, so we dropped the index column. This is the code. This code drops the index column. As you can see here, drop column, the index. Here we have the index, so we just want to drop that one. We are trying to filter the data to as well to an appropriate level. But when we do that, here we watch this one again. So here we are trying to match the two. So population density. So we are trying to look at it. So we are trying to match the two, this particular data set, with our geometric data, the geographical data that we earlier loaded. So when we do that, we are going to have 983 rows and 17 columns. And then to have the view of it, you can look at the head of the data, the new data. So our new data is now in PPD. So it means we've merged it. So, and then this is a function that we use to merge these two data. And how should they merge? They should merge from the left using this identifiers code against this. So where here you see that in the first data set, this column, the EEE is at the code, and then the geometry column, the EE aspect, the E00 something, which is identifying the location of this particular thing, data point, is having a column of this. That is how we match the two by this, because they are the unique identifiers, simple unique identifiers over there. So now we match them to confirm whether the data set has actually merged. We can look at it from this. So you can see here that the code has merged accordingly. So to confirm that it has done the correct way, you see that E02001, the last one is 1. You check those things to confirm that it has merged appropriately. So if you are being asked how many MSOAs are in the PPD data set, is just trying to ask you how many boroughs are in this particular data. It's just like how many cities or how many communities are in Accra. That is the meaning of it. So you can just find that by using this shape, because I want only the column and I need to give you those things. Now, so we are going to use these values. We are going to, over here, we picked the index again, we created the SOEs. That's how, this one we are just looking at two, the index, the code, these codes that represent the unique communities, and then the values only. So you see that we picked only the unique and then the values only. This presents only to the first two headings of the particular new data sets that we have. So from there, then we have to create a legend. So when we create a legend, these are code that are preparing us to run our clustering. So this is just a code for mapping that you have to look at if you receive. Since you have this one, you can, if you want to understand it, you can also copy the code and give it to chat. What is this code doing, to get a clearer picture of it. But at the end of the day, it's just building the platform. It's creating the platform ready for us to run the code. And the same thing is happening here. These are libraries that we are calling to get ready for us. So we load the SMOAs, which is this one again, and then put them into the landing. So we create them to be, we separate them to be the landing ones. And then this will be the headings of them. If you want to look at the landing SOEs too, you can also look at it from here. You see that we have the geometry of the landing space, and then the columns that are in that particular population. So the data set. So it's just the population density data that we just loaded recently. So right now we have the geometry, which are the shapes of the communities or the map of the communities. And this is the population density data that we are loading. And also, it also has this geometry aspect. And it also has this unique latitude and longitude stuff. And it has other unique columns that will find out what they represent. When you go to the website of that particular data set, you see a metadata explaining all these things. So we are creating a refined data set, what we want to use from this particular data set out of this major one. And what we need is the unique identifier of this particular neighborhood, and then these other columns, and then the population density. This is the population density of each of the unique identifiers. This identify the various boroughs in that particular landing space. And then after we've done that, then we then match the population density with the already created PPD data frame. So when we match them, we now have 983. First, we had 983, 17 rows, but now we have 21 rows. If you want to look at it, you can visualize it. Look at the head and see that we've added new values, which is the property value. We have the usual, we will see the meaning of these abbreviations. This is the number, this one also, but this one represents the population density. The explanation is there. We'll look at it. Good. So we have our full data set. Every column that we need to do our clustering and our plotting and stuff is now in a PPD file with merge. So it's not often available in a single data. If you want to do any analysis, sometimes you have different pieces of data. You have to download them and merge and create a new column and create it in a one column for analysis. Most of the times, most of the in-depth analysis that you want to do or you do doesn't have the data sets ready. It doesn't have it clean up for you to pick and then use. They are in pieces. So you go to the this landing data store, you go to maybe another website to download the data and come and merge them. And that is what has been done over here. Now, so let's just look at a raw mean house price distribution in London. Let's just plot a map and look at how the average house prices is distributed in London. So we have this map here, and then have a heat map here. So we have it here to the color coding. The higher, so it means the higher values, areas with higher mid values are in yellow. And this place that you can see here, if you've seen the map of London before, you see that these places are the central London places. So house prices in these particular locations are so much expensive. And then this particular could look like the Westminster area, Kensington area, if you've studied the London map. This kind of analysis, when you do them, to be able to identify where these kind of things are happening, you need to go and then watch the area map of the particular location to know that, okay, this area is, because I've watched it before, that I'm able to tell. But you can't just tell from this plot that this is Westminster or something. You can just go and watch them and see where they are located. So, but largely these areas are all central London. So it makes sense when property prices, the average property prices, they are more higher than any other places, largely. No. So we look at the variable selection to do, and then the things I sent to you, the Python file I sent you is really in-depth. So there are links to other documentations. The functions that we use in this analysis are all having links. If you want to read further to understand, you will get all those things. So this documentation is when they develop the package, they write a lot about what the package can do. That is what we call the documentation and how you can use it. So if you want better understanding of these packages, you can read further. Now, so here we use a robust scaler to standardize the data before we run it. So if you run this, we are going to create using 10 and then 90 points. These are the just input, the range that we are looking for from the robust scaler. So when you do that, we just try to visualize. When you run this, you are preparing the data too as well. So this is just a package and then the functions that you are calling. So you see there's no link to the data that we have in that particular code. So just let's look at our data head again, which is there. So when we look at data head, what it means is that the pop then is representing population density. The value is the mean house prices, and then the useless are the number of usual residents. So number of usual. So this is what will make sense to you, but this wouldn't make sense to you. Number of usual residents. then each holders, that is the number of household residents in that particular thing. And then with this, and this, we should include these particular IDs and then stuff, and then index of the MSOAs too as well. Then to look at the raw, so now we are creating the raw data. So let's create a raw data here, which we selected specific columns to create and use this particular index. We use this particular index to create that particular, and then this is the head of it. So you see, you have the this particular column, which is the number of visual residents, and then the number of residents, household residents, and then population density, and then value. So we have treated this. Let's look at the distribution of that particular data points to in maybe 150 beams. So you can see a plot can tell you how your data or the frequency of this point, so kind of skewed, and their frequency too as well. Now we go, so preparing this data, we are trying to look at a range over here. So norm, and then we call the new data set that we've created here, and then visualize the head after running this particular code to look at the range of each of the column that we have, and then to print all part of the standardization, the scalar aspect, normalization of it. So you see that it has converted the values into continuous data to be used and stuff. So let's just look at need. We can then look at the how it is scattered around the scatter plot of it to look at the population density and the value as well. So let's see population density against the value. Value in this case is the property price. And one question you can also ask yourself is that, does population density imply a higher average of house price? You can think about it, take around those ones and see if you can have a good reflection on that particular question. If more people are in a particular location, will it increase the house price, the average house price in that particular area? And so if you look at the scatter plot, you could see that our outliers are there, see how they are distributed. Then we move on. Then we are now come to do our function. The functions or mapping clusters, we are trying to, so we are trying to label. So these are all functions that we are trying to call to help us carry out our clustering. This code is doing the same thing. If you want to understand how this code is doing that, you can read further here to understand the functions. I provided a link under this particular function for easy access. Yeah, this code and then the comment in the code, if you want to take them one by one, time will really go. It's already almost 5 or 4 over there. So since you have this one, you can actually go through it slowly if you have time. Now, so these codes are all preparing the environment for us to be able to run the clustering function. So the first one we're going to look at, as mentioned, as the things we are going to be looking at. If you want to also understand the DB-scan, which is the density-based spatial clustering of applications with noise. Noise is kind of an outlier. Noise in a normal sense, in ordinary terms, is outliers and stuff. So it's not anything big. And if you want to understand it more, you can read the documentary and get better understanding on that, further understanding on that. And in the DB-scan, there's no way you're going to do clustering without, anytime you're reading a paper that uses clustering, you always come across DB-scan or other kind of clustering. This DB-scan takes in 2 major parameters. Just two parameters. The first one is the epsilon. Epsilon is, this particular is shortened as EPS. Epsilon is actually the it is the distance. It looks at it from the distance. Sorry, if you are, since you are in the room, let me put it this way for you guys to understand. I'm sure you are in the elevator. You are all seated in a particular distance. Who can you call a neighbor in that regard? Who will be your neighbor if the distance between you and your other seated partner is that close? The tendency of you forming a cluster is very high because the distance between the two of you is not that huge. If another person is far at the back and you are in front, the distance between the two of you is huge. So therefore, the two of you can never be cannot be clustered in the same group. So that is what you said. So that epsilon, the short form is the EPS, gives you at what distance should I classify a group of people as neighbors? At what distance? So you set that particular distance for them. And then the minimum samples, which they call the mean points, the minimum. At how many points should I group as clusters? What's the minimum point should I get before I can cluster them? So I have about 30 points. I said, oh, if they fall within this particular distance, which is the EPS, and then they are this number of points, cluster them as one group. That is what the DB scan actually does. And you don't have to do that manually. The code is just right there. So over here, you see that we set the distance to 0.2, and then the minimum point we want is 5. So when you run this code, it has created a map of clusters. But so if you read the DB scan very well, documentation, you realize that when you have this, someone who, if looking at it just by a glance without knowing what DB scan does, you think there are maybe 5 clusters here. No, but DBs can always consider the negative cluster, which is represented by this color from these sections, to be outliers. So it groups all the outliers, it clusters all the outliers in one group. Clusters all outliers. So in effect, the actual clusters in this particular map plot is just from 0 to 3. So in all, there are only 4 clusters in this. And we'll go further to see how this is true. Good. So I've already talked about this theory. This is what I just mentioned. So it's also in the documentation. You can also reach over there to get it. Now I want to see the clusters. How many points each cluster has, or how many points has been considered in each cluster, or how many points are in each cluster or in each group. So in here, you see that the green one, the cluster 0, has a lot of points if you look at it just from the map. And then it followed by which one? The rest are maybe this one. So let's just look at it. So you realize that cluster 0, like I said, when you run this code, this is just a code that you are calling the DB scan to count the points that you use in clustering the design for you. So when you call it, you see that it gives you the number of clusters, but of course, the -1 cluster is always considered as the outliers. So that one, we don't count it as a cluster. So 0 has about 759 points. Then cluster 2 has just 8 points because I had set the minimum points that cluster should have to be 5. So the cluster 3, see, though it's just 5, it has formed a cluster. Good. So we can also visualize these particular clusters using what we call the radii plots. That is here. This code will also help you to plot that. This is what we call the radii plots. This also helps you to appreciate how this particular points influence the clustering. Which of the points? So we have the value we have population density, we have I've forgotten the name. This particular one where is this is the number of households, resident households, and then this one we've already, you can go back and look at it. So we want to look at, so you see with the red cluster, which is the third cluster, you could see that the value influence the clustering more, and then the other factors impacted it less. And then over here with the green one too, you can see that value also contributed largely, and then the population density as well. You see that in cluster wasn't formed by much of these values. So I think in a direct proportion or something, you can see that. So this kind of plot helps to see which of the variables are actually influencing the clustering formation and stuff. You can read further on the documentation over here too as well to understand. And then the link, a detailed link for how to describe this particular plot is also here as well. Good. Now, so that is the first DB scan plot. We can look at it. We will look at something very quickly in R. Then we conclude our presentation and stuff. So over here, to test the accuracy of your clusters, we have this particular measure, which we call the silhouette score. This, anytime you do clustering and you want to measure the accuracy of it, this is that silhouette is called silhouette score. So you use this code to assess its score, the performance, or how fit these clusters are. So it's used to actually evaluate how good the clustering results are in the data clustering. So this is just to see if our results are actually good. If they are not, then it means we can further improve like we did in the regression and stuff, and apply other methods and see. So the best, so here, this is how you, the best and worst value of the silhouette score is 1. So if you have a best clustering, that means you should get the score to be 1. If you have a negative one, that means a negative one, it means it's kind of worse. So relatively, values near 0, which in this case is our results, signals overlapping in our clustering. So it means there are points that are overlapping in our cluster. So we can better use other methods to improve this particular thing. So the next one is the k-means clustering. The k-means algorithm divides the data set into predetermined, which is a k. So that one we tell the algorithm, we tell that from this number of, that is why it's all predetermined clusters. So we tell the cluster the algorithm that is trying to solve that particular issue of overlapping issues in the DB scan. In the DB overlapping. So that is, so if you are trying to avoid overlapping in your clustering, you can think of using the k-means clustering. To read more on this particular thing, the k-means, you need to call the package to, or the function to be able to run this. So this code is calling the package. So here you see the K cluster, we are trying to say that form 4 clusters. Since this particular about the potential number of clusters that can exist in our plot. So we will use 4. So in a way, the DBs can help us to give us an idea where So we just go straight to say, okay, create 4 clusters. This code is just setting the this one. If you want to understand it, you can also give it to chat. Chat will also explain it to you to understand it more. But it's just to maintain to maintain that, because things are happening in the machine, the running model, before the results will come out, to maintain uniformity in that particular regard. So here, so after setting up this particular model, we then look at how we can plot our labels. When you take your time to go through it, you understand how these things we've got into this point. So after rerunning the clustering, we now have something else. So we don't have outliers. We have our 4 clusters. So it means the overlapping issues has kind of been mitigated. And then look at what we still have prices, central. This is all central London. When you look at the peripherals and stuff, you see that the central London is actually experiencing more of it. And then the color coding will indicate the number of clusters, which of the clusters we are talking about. So cluster 0 is in the middle. You see all those things. Then in that case, we can also look at the can also visualize it again using the radar plot. So this picks the cluster centroid and then do the comparison. So you look at it, you realize that in these are new radar plots. Look at the green one, cluster 2. It's more influenced by the value and stuff. See that there has been a slight change in the plot. So this is also a theoretical thing that you can read to understand the K-means clustering. Then findings, we can also look at the findings. So this documentation will also talk about this one. So if you click on it, it will take you to a website to also read more on this particular thing. So the next one is that we are trying to try to use the elbow method, what we call the elbow method. When you read clustering papers, you'll see that they use all these things that I'm mentioning to assess their analysis or their clusters. So the elbow method to choose the K value, where the K value is the number of clusters. So the idea behind the elbow method is to identify the value of K where the distortion begins to decrease most rapidly. So at this value, if you continue to increase the K, you will not get much decrease on the SSE. And then we'll see what's the SSE. As I think we didn't read that place. So when you because we'll see what's the inertia, what we call the inertia aka SSE is. So you see that what is being said here in this plot, you realize that we have here, we are dropping, and then all of a sudden around 3. So you see, let's say around 3, we can actually draw a straight line over here. So saying around 3, all our points start dropping rapidly. So we can say that this is the point where inertia, we all understand, you can get the inertia meaning, you know what it means at a point where the other curve is dropping rapidly. So we can see that from here, all the points are dropping rapidly. So we can choose our K to be 3, around 3. Now, this is all trying to improve our clustering method. So in this case, our K is 3. So less than, according to this plot or this particular test, is saying that our clusters, the best clusters should be 3 or something. So let's use our K to be 3 and see how our cluster will look like. So anybody who pick your clustering analysis, so that, okay, you did a DB scan, you try to improve it, you're trying to do the best number of clusters that the data point can represent. And this particular one is helping us to say that the first one told us 4. The DBs can give us an idea about 4, so we try to use 4. Now we tried the randomness of k-means, and then we tried this particular approach, which is the elbow method, to see if truly the 4 represent the best clustering. And then when we tried, the elbow method is saying that the best could be 3 clusters. So now we are come to rearrange our model and put the k and identify the k to be 3, or specify the k to be 3, and see how our plot will look like. So we set our code up, which you can go through, and then we use 3 as the clustering, and then set our seed. This time we've changed the seed a bit, and then use a cluster. So you see that over here we had the best kind of good clustering, but cluster 1 still indicates central landing in other places. But I think this has improved our best one. We couldn't have settled for the first clustering. Now, after doing all these things, we have the next clustering method, which is called the hierarchical clustering. And to read more about this, we also have link on the notebook that has been shared. You can also look at tutorials to understand the hierarchical clustering. The hierarchical clustering is just an improvement on the DB scan. And then when I show you this particular thing that I did in R, you can appreciate it more. Now we're going to run through it as fast as possible. Then we set it, and this creates what we call a dendrogram. These things are kind of used to visualize or see where the clusters are occurring. So when you look at this, and they say the net, so we look at it and realize that between 10 point something, a little bit above this, and then we had a break. So that is where the clusters start forming. And this is mostly used in, these ones are also used in urban simulation, modeling transport models, developing transport models to develop where clusters are being formed and stuff. So these dendrograms can also help you to visualize how and where these things are happening. So a bit of literature here to understand this particular thing, since you have the notebook already. Then we plot the clusters again. This one is just the fourth one, the very fourth one that we did, just to call it again and understand, see how it is being formed. First clusters having this number of this thing is forming over there. It tells you the number of points that is formed in that particular thing. Then this also tells you the point at which they are represented and what the dendrogram is also representing, and then how you can link the clusters to the dendrogram plot. It's also mentioned over here, as you can see from the Python notebook. Now, the last one that we are going to look at is the regionalization method, which is called max P problem. And then this is kind of new. The tutorial is right here. If you can watch that one and then see how it also works, that will also help a lot. And then when you do that, this is the code. We just, for that one, region, that is why it's called a regionalization. It picks a particular area. So in Accra, I just want to know how the data or house prices or values are being distributed in only Adenta space. So that is the region only, not the broader aspect. So you can pick a particular region. And in this one, pick Camden, and that is where I am, Camden, almost close to the central London. Camden is kind of located around this place. So it will definitely also have higher values. But in that same Camden, we want to see how the point can be declustered. So extract, so in this case, we are trying to extract Camden shape file from our data from the data can only Camden from the PPD data and plot that. And when we do that, we see we have 28 rows and then we have 22 columns in that and the Camden data. Sorry. And this code are also getting ready. We are getting the plotting ready, going through this, and this code will also help us. We are identifying this is just calling the columns that we want. And then we set a threshold. We have the threshold Camden, then we plot. So when we plot, we do all that. You can go through it one by one, take your time and go through it to appreciate it more because time is really going. Yeah. So when we plot the Camden, then this is the shape of Camden. So if it is a dental, which means our dental will see that this is a dental map, and within a dental, this is the number of clusters that we can identify in a dental. So when we pick a dental map, we said, okay, this area going towards this particular side, prices will be. This is how house prices are being distributed in that particular locality or something. Yeah. So this you can read more on this. These are references. And then the data that we used in this clustering methods is from this professor. He has it in his GitHub account, and that is what you can also look at. He has done a lot. That if you want to also look at how these methods have been applied in the housing sector, you can GitHub repository and then look at the works that he has done with this particular his research in housing stuff. So it will be beneficial to you. And if you want to know, get an in-depth knowledge about this K-means clash, another link to is here for you to read. Like I said, after your undergraduate, much of the work is on you even at the master's level. So this is about the first one, how you can do clustering. And this is a machine learning model in machine learning. As for this is how you can go up. Read for there are other things are not here, but if you read other books, you can get that particular thing. Some of the ways you can search this kind of things is that, oh, how do we do clustering in Python? A lot of works will come. Then you pick a good one that you think is relevant, look at how the person went about it, and then get good understanding of this particular method and how they have been applied differently. Okay, I think we have about 1 hour more. So let me quickly take you through how the same clustering method that was used in R. So we are done with the Python aspects. Since you have the design, you can look at it.
Hello, Vincent.
Doc.
Yeah, I'm thinking that the Python should be enough.
Okay. Okay.
Because it's getting late here, and
okay.
I think we've had a lot, and so perhaps we can arrange another section sometime where we'll look at the R programming bit of it.
Okay.
I think at this point we can give them the opportunity to ask questions.
Questions.
Yeah, questions.
No. Okay, then, class. If you have any question, if you have anything bothering you, anything about the whole thing that we did, I know these things to look strange to you. It's normal for it to look strange because it's your first time seeing this kind of thing. Some of you, if you have already seen this kind of things, that is a plus to you. But if it's the first time, don't be worried, don't be bothered. But trust me, this is something that is now a talk of town. And if you have understanding, the basic understanding. You don't need to understand everything. As I'm speaking to you, it's not everything that I can do in it. If I can do, I need to do a lot of research to be able to do it. Like I said, I'm not the best coder now, but trust me, my skills before I entered this program and now it's kind of a bit I can play with data now. That is all that you need to. It's a learning curve. So don't be too hard on yourself. If you don't feel like, oh, I didn't get anything the whole day. It is normal since you have some of this Python stuff. Like I said, the school, let me just type the school that you can easily learn as a beginner, W3 school. If you type this and Google, you should see it, register, and then start learning Python. You can learn that school is good because it has almost all the programming languages there. If you want to learn C++, you can learn it over there as a beginner. If you want to learn Python, you can learn it over there. If you want to learn R, you can learn it over there. So there are a lot of languages over there. Here, I use 3 major languages in my course. I use each model has each model that you need to use, which is a Python, which has been used generally. We have one that we call the NetLogo. NetLogo is used to measure simulations, like interactions between a lot of things, urban stuff. And then most of the time, I remember sometimes when I was applying for courses, I kind of, urban courses are kind of low fashion courses for me. But trust me, the urban courses over here and their relevance in this area is too much. It's too much. So don't be too hard on yourself. Take it cool. This is just an introduction for you. Take it as an introduction. Now, if you have any free time and you want to study, you can take it up. So if you have any question, anything to add on this particular presentation, you can do that. Thank you. And most of you too have my contact. So if there need be and you want to reach out and on any advice, you're working on something, since maybe most of you will be interested in the applications and stuff. I know tomorrow you are going to discuss that. You can reach out and then we'll see how best we can guide you guys. Okay, so any question? I think I'll leave my contact. I still use my Ghana contact on WhatsApp, so you can message me on WhatsApp. Yeah, we talk about it. And this is the time, those of you who want to start working on schools, this is the time. So I'm sure tomorrow all those informations will be presented to you. So just start working, and it's good to seek for advice. Read, don't just sit in your corner and say, I'm writing essays. Do your research, understand a lot before you put down something. That's the lessons we've learned from our experience. So just seek for information, and those seek for people. They said if you want to be rich, you do things that the rich people will do. If you want to be different, you need to be doing things that people top they are doing. Those are the things that makes the differences. It's not about any supernatural stuff. Do the needful. Connect with the right people. And as you go out there, it is the connection that you get that to sustain you. It's not about the grade. After this, no one asks you, what did you get? Or what was your grade? If you get to the end, they learn from you. So this is the little one that I'll say, the little advice. You go out there, do your best. You're about to start your service. And then don't go and be lazy about whatever you do. Try to learn something from the industry. Don't say, oh, it's the norm. Go to work at 10 o'clock and stuff. You see yourself as a global person. I remember when Dr. Sherman came, I was in final year. He taught me real estate finance. And then that was my first time with him as a student. Every day we should go and summarize articles, go and read the articles. Then because we were pushed out of our comfort zone. We're in our comfort zone. Sometimes it was frustrating, but trust me, that was the best approach. Over here, the references that you have to read, things you need to read to understand. If you don't read before going for class, you are as empty barrel. So those are the things students. I was in that shoe, so it is normal. It's because we are not exposed to certain things. We didn't understand. We didn't feel comfortable with it, and then no one likes it when you are being pushed out of your comfort zone. And I'm sure a lot of students will still be complaining about his approach of teaching. You understand? Sometimes we need to create that difference. You need to actually, if you have something and then you come back and then you're doing the same thing, then it means you need to actually implement whatever you study. So that my time, a lot of us was complaining. People can say, and I said, oh, it's fine. We are doing it small. And that really helped me. Because if you come here, the writing you do, you don't go and write exams. Well, like I said, the exams are 6 hours. You are there, you download it, analyze it. So you can never leave the course without knowing how to do something. Even if you don't know how to do everything, you have an idea about where, okay, I've been exposed to a lot of methods, but you, at the end of the day, you know that, okay, if I pick regression, this is how I'm going to use it. I can effectively use it and use it to write a report that will be meaningful to any reader. So I'll say I wish you all the best in whatever you're going to do, wherever you find yourself. Be humble, learn from your bosses, collaborate, build good connections. Don't be lazing around, because one day they are going to request for recommendation. That is one thing that students also fail to understand. When you are a student, your lecturers are there for you to get close to whatever challenge you have. After school, you will need these recommendations. Those of you who have not started applying for schools yet, you will see that they'll say, write 2 recommendations, 4 recommendations. If the lecturer doesn't know anything about you, trust me, recommendations count in your success in securing scholarships. So imagine your performance. Note that you are performing, you are competing with global students, everybody from Africa to, particularly when you look at the Commonwealth scholarship, you're competing with Indians. That is, at least if you won't get to know anybody at all, build that rapport with 2 or 3 lecturers before you leave campus. That is going to go a long way to help you, because when you ask for references and stuff, the lecturer gets to know who I'm dealing with and who the person is. They put in a very strong reference for you. Okay, so it seems I'm talking so much. I'm taking tomorrow's presentation. So if you have any question, let's hear you. And then if you have any contribution based on the presentation, if you have a recommendation to make, if I didn't say something right, and you want to point out something or contribute to that particular thing, can do so before finally we end this session. Okay.
Hello.
Yeah, hello.
Yeah. Please, I want to thank you very much for this great presentation. On behalf of the club, the members of the club, and the entire executive committee, we are very grateful for this presentation. We started that was 8 a.m. So this evening, we've consumed a lot of time and we also learned a lot. So thank you very much for this wonderful presentation. We are grateful for that.
Okay. Thank you. I must say, I'm so happy to be here too as well. It's always a happy moment when you can actually impact, tell people the impact. The little you know, if you're able to teach somebody, even if the person doesn't understand fully, you're able to impact something small, you're able to influence people. If you want for any guidance on the application stuff, we want to right now, I think one Ghanaian is coming to do my course again. Commonwealth scholarship again to get the course sponsored again. So hopefully by the Commonwealth, normally I came with Commonwealth scholarship. Expensive. So you should be targeting that. Just try to see how you can start looking into the Commonwealth application. Use the previous. I can share my essays with you. Go through it. It should serve as a guide for you guys to apply. And I'm so happy you guys cooperate throughout this session. I know it has been a long day, but you guys did so well. Thank you so much as well. And then I also have to thank Dr. Sherman for this opportunity. And then the executives, I also try to encourage you all to keep this club going as this has come to stay. Thank you so much.
Okay then, guys, thank you, Vincent, for spending the whole day with us. I believe they have learned a thing or two. I think the next step perhaps will be to have a section where we will teach Python programming itself.
Okay.
And then they can go through the programming itself and then see how we can replicate some of the things you have shown them today. So we'll discuss this in the background and see how we could plan towards that in the future.
Okay. Okay.
Yeah.
Okay.
Yeah. So guys, I'll see you tomorrow from 9. And so yeah. So all the best. See you. Yeah. Bye.
Bye.